So here the given problem is unbalanced one. How can we say it is unbalanced? Here total demand is 145 and total supply is 105. Therefore total demand is not equal to total supply. Therefore the given transportation problem is unbalanced one. Now let us see how to make this unbalanced into balanced transportation problem. So here total demand is greater than total supply. Okay. Here total demand is greater than total supply and the difference is 40 units. So total supply is lesser here by 40 units. Therefore let us add one more row with cost as 0 and units as 40, that is 8, 4, 10. 979658 and the corresponding supply units are 80, and let us add one row with 40 additional units because supply is lesser here in this problem. Therefore I have added one more row with 40 units as supply and the demand remains the same for all the destinations. Now so here, so let us once again check the requirement for the balanced one. So now the total demand is 145 and the total supply is also 145. So this way we can make an unbalanced transportation problem into balanced one. So suppose if total demand is less than total supply, for example in this problem total demand is more, in some another problem total demand may be less than total supply, then we have to add one column with 0 cost and the leftover units. So this way we can make unbalanced transportation problem into balanced one. So it is the first requirement to solve the transportation problem. So always while solving the transportation problem should be a balanced one. It is the first condition. And the second condition is the transportation problem should be in minimization model. So let us consider one more problem which is in maximization model. So here this problem is in maximization. It is maximization. How can we know whether the problem is whether the given transportation problem is maximization or minimization model? By the data, if we observe the data, if the data pertains to costs or investments, then we can say that the problem is in minimization model. And if the data is related to revenues or profits, or sometimes it is mentioned in the problem that the problem is that the payoff matrix is profit table, then we can understand that the transportation problem is in maximization model. Now let us see how to transform this maximization model into minimization model. So there are two conditions as I said previously. So while solving the transportation problem, then number 1, the transportation problem should be balanced one. Number 2, the transportation problem is in minimization model. Let us see how to transform the maximization model into minimization. So among all the payoffs, here we have 3 origins and 4 destinations. Okay, and here among all the payoffs, observe the maximum payoff. Here the maximum payoff is 25. Subtract all other payoffs, all other elements from this maximum value 25. Then we get the minimization transportation problem. So in the given maximization model, the highest element is 25. If we subtract all the elements from this 25, we get the opportunity cost table, opportunity loss matrix, and it is transportation problem which is in minimization model. And now let us test the whether the problem is balanced or unbalanced. Is here total demand is 1000 and total supply is also 1000. Therefore total demand is equal to total supply. Therefore the transportation problem is balanced transportation problem, and the transportation problem is in minimization model. So the two conditions, these are the two conditions we have to. Therefore, so while solving the transportation problem, so we have to check balanced or unbalanced and maximization or minimization model. After that, there are two phases in while solving transportation problem. Phase 1 is finding IBFS. IBFS stands for Initial Basic Feasible Solution. So after transforming the balanced into unbalanced transportation problem, maximization into minimization, then we can start solving the transportation problem. So the solution of transportation problems happens in two phases. Phase 1, finding IBFS, that is initial basic feasible solution, and phase 2, checking whether this IBFS is optimal or not. If it is not optimal, then by using two methods, that is one method is MODI method which is called modified distribution method, and another method stepping stone method. By using either of these methods, we can find whether IBFS is optimum solution or not. If it is not optimum solution, then using any of these methods we can find the optimum solution for the given transportation problem. So these are the two phases we have in solving transportation problem. So the first thing, we have to find IBFS. So how to find IBFS? So to find initial basic feasible solution, we have different techniques. Totally we have 5 techniques, and the first one is northwest corner rule, and the second technique is row minima method, and the third one is column minima method, and fourth one least cost method, and fifth one, the mostly used technique is VAM technique, which is otherwise also called as Vogel's approximation method. So it is the generally accepted method, mostly, and this technique, VAM technique, is used to find IBFS. Let us see how to find IBFS by using northwest corner rule. So consider this example. So here total demand is 135, total supply, total demand is also 135. Therefore it is balanced transportation problem, and it is minimization model of transportation problem. The first two requirements is over, and now let us find out IBFS by using northwest corner rule. So while using this technique, we have to consider the northwest corner, and this cell 1 is the northwest corner. So let us start the allocation with this cell 1. So here the supply is 20 and the demand is 40. So we have to make allocation in such a way that whichever is lesser one. Here total supply, the supply at the origin A is lesser than the demand. Therefore allocate 50 units to this cell and strike off this 50, and here still we have to supply 10 more, still 10 more units are demanded at the destination D, and strike off this row. And in the remaining matrix, so because here 50 units are to be supplied, so from origin A 50 units are already supplied. So we no need to consider the first row. And this is the leftover matrix. In this again the northwest corner is the 2 1. It is 2 1 cell, and here the supply is at origin B, the supply is 60 and the demand is 10 at the destination D, and here 10 is lesser, therefore allocate 10, and here 50 units left over and strike off this 10. So this column is also over because total demanded units at the destination already we have allocated, therefore no need to consider the first column. And coming to the leftover matrix, again the northwest corner is 2 2. So at this corner for this cell the supply is 50 and demand is 40 and the minimum is 40, and here 10 units left over, and this column is also over. And coming to the this 2 by 2, this cell that is 2 3 is the cell to which we have northwest corner, and here against this cell the supply is 10 and the demand is 20, so lesser number is 10. Strike off this and here 10 units left over, and here it is the northwest corner and 20 units are to be supplied and 10 units are the requirement, 10 is less, so allocate 10, strike off this 10, here 15. So for this cell 15 units are to be supplied and 15 are requirement, therefore allocate 15. And this way, by using northwest corner rule, we can make allocations how many units are to be supplied from origins to different destinations. And now let us compute the total transportation cost according to this northwest corner rule. If we supply different units to different destinations and the total cost is, so here 50 into 3, because per unit cost is transportation 3, we are transporting 50 units from origin A to destination D, and the total cost then becomes 50 into 3. Next here 10 into 7 plus 40 into 5 plus 10 into 2 plus 10 into 4 and plus 15 into 5, and make the total, and the total transportation cost is 50 into 3, 10 into 7 this way, and the total transportation cost is 555 according to northwest corner rule. This way we can find IBFS by using northwest corner rule. Next, let us see how to find IBFS using row minima method, second method. So in row minima method, consider the first row. In the first row, what is the least cost? So it is the least cost. So in this for this cell, the supply is 50 units and the demand is 40. So whichever is lesser, that many units we have to allocate. 40 is lesser, therefore allocate 40. And here 10 more units are to be supplied, and the strike of this column because 40 units are already supplied. Okay, and next, and in this first row still we have to supply 10 more units, therefore in this row consider the next element among the leftover elements. So here the next minimum is 3 and 10 units are required, here it is 60, therefore make allocation 10, strike off this 10, and here 50 remains. Strike off the first row because the first origin total 50 units are to be supplied, we have supplied 50, strike off first row. And in the second row, and the minimum is 2, and here 60 units are to be supplied and the demand is 20 is minimum, allocate 20, and here 40 remains, And because for the second Z destination we have supplied all the required units strike of this column, and the next minimum is in the second row is, because as the name suggests it is row minimum method, so consider each row. So in the second row still we have to supply 40 more units, and minimum is 3. Here it is 40 and it is 15, so allocate 15, and here 35, sorry, 25 remains and 15 left to strike off this column. And coming to still we have to supply 25 more units here. So select this cell, here it is 25, it is 50, 25 is to be allocated, and here 25 remains, and we left over with only this cell. Here 25 are to be supplied, 25 are demanded, therefore allocate 25. So this way we can make allocations according to matrix minima method. And the total cost is, total transportation cost is 10 into 3, 40 into 2, 25 into 7, 20 into 2, plus 15 into 3, 25 into 2. ఎంతో